Hi, in this final lecture for the course, I just want to go back and think about some of the reasons we initially gave for why you might want to learn models. And we want to talk about sort of how the models we've learned have helped us accomplish those goals. So remember, the first reason we had was just to make us an intelligent citizen of the world. And let's think about some of the models we covered in this class that help us become more intelligent. So we learned the growth models, and those growth models showed us that countries can accumulate fairly rapid growth rates just by investing in capital. But at some point, when they get to the frontiers of what is known, they need innovation to create growth. But then we also saw that innovation has this sort of doubling effect, that you get the direct effect from the innovation, and then you also get the effect that now it makes sense to invest in even more capital. So we learned a couple interesting things just about different economic growth rates. The Colonel Blotto game also made us a more intelligent citizen of the world. It made us understand that how in some sorts of strategic competition it makes sense to add new dimensions. Helped us understand some of the tactics people use in war, some of the tactics that terrorist groups may use as well. So that model was also useful. We had Markov models. Markov models helped us understand that maybe we shouldn't necessarily think about trends continuing in the linear way, that they may fall off. They also helped us understand situations in which history doesn't matter. So there could be some situation where an intervention, if it just changes the state, doesn't really do any good. But an intervention that changes the probabilities makes us all better off. And that Markov logic is an example of us becoming clearer, better thinkers. Other examples of that are our discussions of tipping points. Remember when we talked about tipping points, we had this idea that, if you see a kink in the graph like here, you could say, oh my gosh, this is a tip. Then we said, no, that may not be the case. That could just be a growth model. So remember, we had that very simple growth model, and that exponential growth model had a sort of an increase, a place like right here where you think, boy, it looks like it's really changing its slope here. But that wasn't a tip. And that what a tip was, is a tip was a situation where the likelihood of different outcomes was drastically changing at a particular point in time. And then we learned the difference between tipping points and path dependence. Now, path dependence means there's sort of gradual changes in what's going to happen as events unfold. So tips are somehow different than path dependence, which in turn were different from chaos. So by having growth models, tipping point models, path-dependent models, Markov models, percolation models, right, which gave us those tipping points, SIR models, those disease models, we had all sorts of new intuitions to make sense of the world, to understand why do some things, perhaps look linear, why do some things look S-shaped, like the diffusion things, and why do some things just take off, like our growth models. So we got some understanding of the shape of things that we're likely to see, and what causes things to have particular shapes. So that was really, really useful. We also learned how to sort of use and understand data. Remember, there's tons of data out there. We did some very simple things like category models, and then we did some more sophisticated things like linear models. And we even did things like prediction models at the end, where we showed how we can combine all sorts of predictions to get the wisdom of crowds. So what we saw is that we can use these models to make sense of all the data we see out there in the real world. We even did it with Markov models. Remember, we sort of linked our Markov model to data. So a lot of our models were abstract, like some of the models like the game of life, right, which just made us a better thinker, which didn't relate to data. But many of the things we did, like the growth models, the linear models, do relate in real ways to data that's out there and can help you make sense of that fire hose of information that's pouring out at you every day, or if you prefer, the hairball of information. And finally, we constructed some models that helped us make better decisions. We did those simple decision theory models. We talked about some very simple game theory models like the prisoner's dilemma, some collective action problems. And then we talked about mechanism design. We thought about, okay, how do we construct a model of a particular situation to help us design institutions, write contracts, design policies, so that we get the outcomes that we want. Now, we only did that in a very simple way, but we still got at some really deep insights, this notion of incentive compatibility. How do we create incentives so that people tell the truth, they reveal their hidden information, or they take an action that we want, even though that action is going to be hidden. And we also saw that sometimes what we want to do may not be possible. So the model tells us what we can do and what we can't do, or the model may tell us, like in the case of auctions, that it really doesn't matter how we do it, depending on how people behave. And on that last point, how people behave, that may be the most important thing about model thinking. How do people behave? We talked about 3 different models. We talked about people being rational. We talked about people following rules. And we talked about people having psychological biases, possibly. And we saw in some cases, like the game where we had the race to the bottom, remember where you had to be 2/3 of everyone else's guess, We saw in some cases how the assumptions you made about behavior had huge effects on the outcomes. And then we saw in other cases, like in markets, exchange markets, where it didn't matter at all, that you're pretty much going to get the same outcome regardless of how people behave, as long as they're reasonably coherent in the actions they take. And finally, we saw by thinking in models that things always don't often aggregate the way we'd expect, right? That somehow when we add up a bunch of stuff, more is different, as Philip Anderson said, right? That when we add up things, when we aggregate, we can get all sorts of interesting things. In particular, we can get systems that go to equilibria. We can get systems that produce patterns. We can get systems that are almost random, and we can get systems that are complex. And by constructing these models, we've learned why do different systems produce different kinds of outcomes? How do we possibly intervene in these systems? What actions are people likely to take in these systems? How are events likely to unfold? How do we collectively understand what's going to happen in these different parts of the world? Now, this course was just an introduction, and it's really sort of baby steps, and it's meant to entice you to look deeper, to take more modeling classes, and to recognize that even though most of us take mathematics, we take calculus, and we're doing things like the double integral of arcsecant of xy or something like this, right? It's a really complicated thing. But we can also use mathematics to try and help us make sense of the world, and we can use computation to do the same thing as well. And so what's nice is, by constructing these models, they're this crutch for us. They help us clarify our thinking. We're better thinkers. We use data better. We can design and strategize better. And we're just more intelligent citizens. I hope you've enjoyed taking this class. I've certainly had a lot of fun putting it together, and I've learned a lot in the process. And I apologize for any confusion and technological glitches and delays and things like that, but we've done the best we can do. I particularly want to thank Tom and Leah, two undergraduates at the University of Michigan, who've helped me throughout this whole process. They've just been absolutely fabulous. They've given me incredible support, and they've helped a lot in all sorts of ways you can never imagine. And to all of you out there taking this course, again, thanks a lot for everything you've done. I appreciate all the friendly and helpful comments you've given along the way. And as we like to say here in Ann Arbor, go blue.